Imagine a small particle, like a proton, speeding towards your hand at 99.99% of the speed of light.
Would you feel anything when it hits you? It was the night of October 15, 1991.
A mysterious particle was racing through space with the energy of entire stars encapsulated in tiny atoms. Its energy was 40 million times that of the most powerful protons ever produced in our most advanced particle accelerators, like the Large Hadron Collider.
Furthermore, it was incredibly fast.
Its luminous trail even broke the speed limit of particles. According to some scientists, particles traveling at this speed should slow down sooner or later. But this one didn't follow the rules. It kept moving just a bit slower than the speed of light. Scientist John Lindsley was so shocked that he exclaimed, "Oh my God," when he first saw the data. So, that's what they called this thing. The "oh my God" particle. Now imagine a normal particle like a photon traveling through space alongside this crazy runner. Well, the "oh my God" particle has energy that is 100 trillion times higher than that of photons. From our perspective on Earth, it would take over 250,000 years for the photon to gain even the slightest advantage. Looking at its energy, it would be like a baseball thrown at nearly 60 miles per hour, which would hurt if it hit your bare hand. But surprisingly, if the "oh my God" particle were aimed at you, you wouldn't feel anything. It would simply pass through your hand. It might scatter some other particles around, but overall the impact would be imperceptible. And all of this is due to how cosmic rays work. When you are in space, there are tons of invisible particles moving around you at incredibly high speeds. They are like tiny, supercharged balls of energy. These super-fast particles are called cosmic rays. Usually, we encounter the consequences of their atmospheric dance at sea level. Most cosmic rays are composed of single protons with just a sprinkle of heavier particles. The higher the energy, the rarer the ray. They come from various places in the universe. They come in two variants: galactic cosmic rays from outside our solar system and solar energetic particles emitted by the Sun. We are mostly protected from them by our Earth's magnetic bubble, the magnetosphere. This protective shield deflects many charged particles, including cosmic rays, away from our planet or directs them towards the polar regions. And guess what they cause there? That's right, the famous and beautiful aurora borealis. The northern lights we often see in the Arctic and Antarctic regions of Earth are caused by travelers from outer space. But it's not that none of them ever reach our planet. In fact, we are surrounded by cosmic rays. Everywhere, thousands of these rays dance around us every second. And not only do they surround us, but they also hit and pass through our bodies. However, we don't feel anything. This is because, although they are very energetic, they are still super small and of low mass. In fact, they are so small that they often pass through the spaces between atoms and even within the atoms themselves with minimal interaction. Because of all this, we had no idea they existed until the early 1900s. A long time ago, scientists discovered that the air at high altitudes contains a special substance called ionization. Ionization occurs when atoms or molecules gain or lose electric charges, turning into ions. Simply put, it's like giving a neutral thing, an atom or molecule, a positive or negative charge. These charged particles can then do some interesting things. For example, they play a crucial role in electricity, allowing things like lights and electronic devices to work. In any case, scientists wanted to know where the ionization came from. Initially, they thought it came from radioactive things in the ground, but then, in the early 1900s, a couple of scientists went up in balloons and discovered that this ionization increases as you go higher. It turned out that something coming from space, not the sun, was causing this ionization. Scientists have learned a lot over the years, like where they come from and what they are made of. And thus, the phenomenon of cosmic rays was discovered. The mysterious, "oh my God" particle we talked about was one of those cosmic rays. This particle was detected by the Fly's Eye camera in Utah in 1991. And to this day, it holds the record as the highest energy cosmic ray ever spotted. Of course, it piqued the curiosity of scientists. They wanted to find out where this supercharged particle came from and how it reached its incredible speed. So they decided to investigate, and the more they studied it, the more strange things they discovered. For instance, they found out that time itself dilates for this particle because of its insane speed. Special relativity, an idea created by Albert Einstein, states that when you increase speed, strange things happen. And when you get close to that light speed field, time starts playing tricks. For example, if the "oh my god" particle started its journey from a point 1.5 billion light years away, it would seem to the particle that only about 2 days had passed by the time it reached us on Earth. Since scientists discovered this astonishing "oh my god" particle, they have found hundreds of similar super-energetic events in space. But it's extremely difficult to understand why they move the way they do.
All theories have their problems and obstacles.
One suspect involves supernovae, or massive stellar explosions with magnetic fields and energy. However, it seems that even their great energy is not enough to create an "oh my god" particle. Another suspect is the nearby active galaxy of Centaurus A, but the evidence supporting this hypothesis is tricky because the Milky Way's magnetic field alters the paths of cosmic rays.
Sure, there are some crazy and exotic possibilities, like topological defects from the Big Bang or mysterious interactions within dark matter.
Scientists are exploring wild ideas. Who knows, maybe it's really some quirky twist of physics.
Even high-energy astrophysics is extremely useful for studying and understanding cosmic rays.
This is a field of study that explores highly energetic phenomena in space, like extreme cosmic events. Scientists are interested in understanding how cosmic rays are connected to these wild occurrences happening out there. Unfortunately, even after nearly 30 years of investigative work, the true origin of the "oh my god" particles remains a mystery.
Fortunately, recent studies may provide us with some clues to the answer.
In the vast desert expanses of Utah, there is a thing called an array telescope. This searches for super-fast particles called ultra-high-energy cosmic rays. Imagine a massive grid of detectors spread across the desert, keeping an eye on the particles all day long. Here's what they recently discovered. There is a specific area in the constellation Ursa Major. Initially, scientists didn't give it much weight, but then they carefully analyzed the data and realized it was important. This exceptional area is a hotspot from where these cosmic rays might originate.
It has almost a 100% chance of being real.
It seems to be the hidden energy source of the universe. But what is this source? And why does it exist? The answer might lie in some of the most extreme and violent events in the universe. The latest theories suggest that sources of high-energy cosmic rays might be linked to phenomena like active galactic nuclei, neutron stars, or the jets of particles emitted by supermassive black holes at the centers of galaxies. These extreme cosmic objects have incredible magnetic fields and energies that could accelerate particles to near light speeds. Another fascinating possibility is that high-energy cosmic rays come from catastrophic events like galaxy collisions or gamma-ray bursts, which are extremely powerful explosions of gamma rays that can last from fractions of a second to several minutes. These bursts are among the brightest events in the universe and could be responsible for producing particles with incredible energies. To get definitive answers, scientists continue to improve their instruments and develop new detection methods. Telescopes like the Utah Detector Array and similar projects around the world, such as the Pierre Auger Observatory in Argentina, are helping gather valuable data on the origins and properties of cosmic rays. These advanced instruments can observe and analyze high-energy particles with unprecedented precision, offering crucial clues about where and how they are generated.
Meanwhile, the application of cosmic ray technology continues to grow.
As mentioned, muon tomography is a revolutionary technique that uses cosmic rays to examine dense structures like pyramids or volcanoes. This method has already led to surprising discoveries and promises to provide even more information as the technology evolves. Another emerging field is the use of cosmic rays in the search for dark matter. Dark matter is a mysterious form of matter that doesn't emit, absorb, or reflect light, making it invisible and detectable only through its gravitational effects. Some scientists hypothesize that high-energy cosmic rays might interact with dark matter in ways that could reveal clues about its nature. Despite the challenges, research on cosmic rays is one of the most exciting frontiers in modern physics. Every new discovery brings us closer to better understanding not only the universe we live in but also the fundamental laws that govern it. With each "oh my god" particle that passes through our instruments, we learn something new, getting a bit closer to unraveling the secrets of the universe. And who knows, maybe one day we will discover the true origin of these enigmatic cosmic messengers and their role in the grand story of the cosmos.